Hi, welcome to part 4 of this tutorial series. I think I left a few things out when I did the third part, so I will be adding a few more examples and explain a bit more about the values, and this time we will show a bit what happens and when we mix them and how we can mix them, the different operations that we can do. So, okay, let's start. When we mix two values or make an operation with two values, or in the case of the vector, with two sets of values, what we are doing is making that operation for each point of the map we are plugging. So, for example, in this case, we have -1 here and 1 here, right? Because we separated the values that come from the object coordinate, and we are only seeing the values for x, the changes for x axis. So we have -1 and 1. Okay. What happens when we multiply the same value again, every single point from one value, from one map, got multiplied by, in this case, the same map. So we had 1 here in both cases. So 1 multiplied by 1 is still 1. And in this case, we had -1 for both cases. If you multiply -1 by -1, you get 1. So now we get this shape here. So there are basically 3 different colors of nodes that affect our coordinates or our values. The purple socket that contains the values for the 3 axes at the same time. The yellow socket behaves exactly the same way. I'm not sure if there is any difference between them. I think it's more because one is more related to color and the other one to axis, but they are almost the same. Even if you, for example, you separate here XYZ and separate RGB, apply the same coordinate, and we have X is exactly the same as red, Y and green, and Z and blue. On the math node, we can do operations on one value, but that doesn't mean you cannot plug a purple value here. It will try to transform or convert. For example, if we plug this here, I will add 0 just to see the result. You will see that we have this value. The separate values are gone because we see only black and white instead of the 3 colors. But we still have value. The value here is, for example, in this point, we have 1 for Y and 1 for X, but we have 0 for the Z. So the result is 6.66 value, because it takes the 3 values and divides that number times 3. This is a vector math node, and here you can make operations keeping the 3 values separated, and you can affect them separately. For example, you can take this and multiply, for example, X by 1, Y by 2, and Z we will leave it 0. If you connect these, you will see how the shape changes a bit. So you can manipulate them separately, and you will still have the coordinates separated here to use, for example, as a vector or of a noise texture or whatever you need the purpose. On the mix RGB, as I told you, it's a bit the same. It behaves a bit different because you don't have the ability to change values separately, but you can, for example, plug this here, say mix. It will take 100% of this color and nothing from this one. And if we plug this, you will see that we still have the map separated in colors, and the 3 values are independently still going through the output here. And we can, for example, multiply by this number. In this case, it's 1 top, but you can force that with a value node, and increasing that, you can go beyond 1. The factor is at 0, so if as we get to 1, it starts to multiply by 2. And if we change this, you will see how this affects the values. Generally speaking, we use the vector math node to alter our coordinates, and we use the mix RGB node to mix different values in different ways because we have a lot of blending modes and a factor. And we use the math node to make operations between 2 values that are already separated. We will do a little example for each of these nodes to see how they work. You don't have to fully understand this, but for example, if we have a Voronoi texture. What is interesting about Voronoi texture is that it also has a position here, as you can see, output, that gives us the position of each of the cells of the Voronoi texture. So for example, here I will change this to 2D to ignore the C value since we are using a plane. And I will use vector math, and I will subtract the position of our cells from the position of the world. And that will give us a coordinate that is centered on each of the cells, as you can see here. Then you can create different shapes inside of each cell, and that works for spheres and other objects too. And we will be using that in some cases. So in this case, we needed a vector math node to handle the 3 values at the same time from the different purple outputs. In the case of the RGB node, we can use it, for example, to mix 2 different noises. We will make one like 50 and the other one 5. We will connect these to the 2 sockets. Let's start with mix here. Since this is all the way up to 1, we are only seeing this noise texture. As we move this to the left, we start seeing the other texture too, and you can make a mix of the 2. If you are doing a bump map, you have to take in account that you can make the texture that looks bigger here, assign more value to it. Let's say this is the 1 and this is 0. So at this point where we are saying this noise texture will go to 0.88 or would be something like this. And this texture will be taking the other percentage, so we will have something like this on the top. So when you're creating bump maps, this is important to understand the way to mix them because if we just see at the picture and we mix it like this, you will get something like this and a lot of small but very tall little bumps on the top. So it's important to assign the value that corresponds to this difference, or depends on what you're trying to create there. And for example, for the math node, the most common is when we separate XYZ and we want to combine them or alter them, we will use a regular math node. We can use, for example, in this one, I will use both. I will use here absolute. That ignores the sign of the value, and -1 becomes 1. Then we use a maximum operation here, and we use a range or a greater than. To create a square. You can also use smooth maximum to make round corners. One of the things we use a lot is, for example, length. That gives you the distance from 0 to in every direction. So if we plug this here, you will see, like in the plane, you will see like a circle that starts growing in value, or that starts increasing value in every direction. If we use a map range, the map range allows you to change a scale. We select the range. For example, here we have 0 to 1. We will say, now take from 0.5 to 1. That means 0.5 to 1, and make it our new 0 to 1 on the output. Why this is 0, and if you see that also it's clamping on 1, why that doesn't continue, is because we have the clamp here. If we take the clamp out, you will see how the value also continues in the linear interpolation here, and also goes to above the 1 value. So what the clamp does is limit whatever comes out from here to the minimum and maximum value you set here. As you can see, the length operation has a vector input, purple, but the output is gray, so you have only one value going out here, one map. The same happens on the separate XYZ. Let's make a little exercise to see how the operations work. To see both values at the same time, I will use, in this case, maximum. That will show us the maximum value for any of the two inputs for each point. In this case, we have the two shapes there. This is the actual shape, as we already saw, and this is the projected value. In this case, the center has a value of 1. That's reaching the 1 here. If we use maximum, as we said, it will use the maximum value for any of the two inputs. And as you can see, if we put them together, they won't change. It just takes the one that is higher in that point. If we change this to add, for example, we will see how as they start touching, you will have that point, the point that overlaps will add the two maps together. So if we put them exactly on the same spot, you will be reaching 2. When we, for example, multiply this, you will see here on the parts that any of the maps has 0, everything becomes 0. And on the parts that there's value, we still see value there. This is why we use a lot multiply to make masks, because with 0 you just remove anything, and with 1 you leave it as it was. Same goes for subtract. You can see how in this case we are subtracting the one that goes on the second socket here from the one on the top, and as we place them on the same spot, you get 0 because we are subtracting two identical maps. And the same goes for every single operation here. I'm not going to teach math. I'm not an expert in math. You don't have to be a super mathematician to make procedural textures, because even if it will help you, of course, but on probably 90% of what you do, you will be using simple operations. So don't be afraid of that. Okay, so I think we completed a bit more the information of the different nodes and how we mix them, what the different colors mean. Next episode will be more focused on start making different materials and using this in a practical way. Thanks for watching, and see you in the next video.